Yes, as Michael said. All your secrets are belong to us. The title is intentional. It's a take on the zero wing line. Yeah, I've gone with something fun. Just before we kick off, of course, I want to say a huge thank you to the DDD Melbourne team for having me here to speak, and also to all of the different sponsors of the event, without whom this would not be possible. And make sure you play along with the bingo on your lanyard, and also leave feedback for this session afterwards. So, like I said, all your secrets are belong to us. Today we are going to be talking about secret management in and around the .NET space, but not specifically with .NET necessarily. By a quick show of hands, people in the room, would you say you are a developer? Okay. Anyone not a developer? Maybe it's easier. Cool. What are we working with?
I'm a documentation guy.
Documentation. Cool. Anyone else?
SRE.
SRE, fine. Data, cool. That's fine. There'll be something in this for everybody. So, yeah, we're going to talk about secret management. Secret management is something that ultimately you will be working with on a daily basis, whether you realize it or not. We all have secrets, API keys, etc. in the applications we're building, and keeping those as secure as possible is important. What I will say before we start is, whilst this is a security-focused session, this is also a zero-blame session. I'd like us to all be open and honest with each other and talk about some of the mistakes that we've all made in our own work as well. It's a safe space, don't worry. So, quickly, a little bit about me. My name's Callum. I'm on Blue Sky, LinkedIn, and unfortunately still Twitter at that handle. You can reach me there. I'm a .NET developer by trade, a Microsoft MVP, and I work with an open source web CMS called Umbraco, which I'm also an MVP for. I run a consultancy called Bump, based out of the UK, but I moved here 3 months ago, and we're trying to get set up over here, and I'm loving life here so far. Get to speak at lots of events all over the world and meet lovely people like you. So that's a bit about me. Now, by a show of hands, how many people in this room own a password book? Zero blame, like I said. One person? Okay.
Is that just a notepad?
It's basically a notepad with a fancy wrapper around it, yes. However, maybe we should reframe this. How many people's parents might own one of these? Okay, there we go. See, as people working in web dev or in software as a whole, we know about good password hygiene, good security hygiene. Unfortunately, quite a large part of the rest of the world do not. Password managers, we know that a password manager is probably the right thing we should be using to store our passwords. We know that we should probably be using completely random generated passwords or phrases rather than pets names, etc. But we are absolutely the exception to that rule. Most of the world is using this, or has a note in their phone that shows the different places that they've got accounts and the passwords for them. So really, this is fine, but I'd love us as a community to be able to educate our end users as well on better practice. But that really starts at home, because whilst we'd love to say, yes, we don't use a password book, who can hand on heart say they've got every password in a password manager and it's randomly generated, you're not reusing any passwords at all? Few people. Cool, good for you. It was about maybe 20-30% of the room that said that. The rest of you, maybe think about it. I'm not here to preach and tell you, you should do this, but at the end of the day, it's good practice, and we know it is. We just maybe don't do it ourselves. How many people can safely say they've got two-factor auth on every single service they use that supports it? Yeah, again, about 20-30%. We all try, we all know it's the right thing to do, but it's annoying to set up and fiddly, and you're like, I don't want to have to go and grab my phone or a hardware token every time I want to log into something. So, yeah. We have one set of standards that we know are right, and maybe we don't always abide by them. And we're not the only ones. I said this was a no-blame space. Well, Microsoft have screwed up before as well. A very notable issue, a leak that happened in late 2022, early 2023. They managed to leak 38 terabytes worth of data, sensitive data, including emails, etc., to the public internet. Well, how did this happen? Of course, they didn't intentionally do this. A researcher at Microsoft was making a tutorial for some AI integration, showing, oh look, you can index loads of data out of M365, put it in a storage account, and then you can let an AI tool go and process that data and do things with it. And then they included a video where they showed how they were building this integration, and in that video included a SAS token. This is like a URI that Microsoft allows you to use as a way of authenticating against a resource. Unfortunately, that SAS token was publicly accessible and available, and it meant that anyone could take that very token, connect to that storage account, and see all of the data within it, 38 terabytes of data. Everything from documents, personal documents, to Teams messages, to emails, all available in this one account. Because you had a token that had been inadvertently exposed in a demo of someone recording something on a local machine, and then put on the internet, and it wasn't protected or secured. Equally, Okta, a platform that we trust with a lot of our secrets, they run the platform Auth0, and they are responsible for identity management for large applications on the internet. Well, they've also had a breach, not intentionally again, where somebody managed to ask an engineer on their side to investigate something and send an HAR, a network dump of them replicating some behavior. And in that network dump included an access token that was replayable and reusable. So someone was able to take that access token and actually query it against an internal Okta system. Now, of course, this wasn't against necessarily the Okta identity service, but it was against their internal support system, which has got customer information, etc. in it. Again, another way of inadvertently leaking something. That token should not have been reusable. It should have had a lifetime far shorter than it would have taken for you to send an HAR file to someone, but it happens. The more interesting thing about this breach is the way it was detected. Is Cloudflare, the famous DDoS management and an infrastructure company, they actually picked this up through their infrastructure and noticed that people were making requests to services outside of Okta's network that they shouldn't have been, and using these replayable tokens. And they actually alerted Okta to it, who initially said, no, there's no way that's ever possible. And when they looked into it a bit more, turns out, yes, it was. So Cloudflare got a 10-day heads up on Okta, because Okta didn't necessarily have that kind of monitoring in place. As I've said, no blame here. This happens to even the big guys, so don't worry. I think the key message I'm trying to bring across here is, whilst there's no blame, the best thing you can do is hold your hands up and say, yep, something's gone wrong, let's fix it. Okta, in denying for 10 days that this was even a possibility, essentially left that window open even longer for where their service or their support system, in this case, could be exploited. So the best practice is put your hands up and say, yep, all good. Let's find a solution to this. So, as I've said, there's some key ways we can prevent this sort of thing. The first is 2FA. Put 2FA on all your services, right? If you've got a personal account or a company account or something, that really should be on everything. If possible, avoid keys and tokens and sharing those around, or if you are going to share them around, make sure that they've got short lifetimes or are only accessible from certain places. Even better, use other forms of authentication that don't rely on this sort of mechanism, like a hardware key or some kind of biometric auth. Another really important thing here is cycling of these credentials. If those credentials do leak, but you cycle them every 30 days, 90 days, every 7 days even, through some automation perhaps, then you're massively reducing that window and hopefully reducing that attack vector. And finally, monitoring is possibly the most important thing, and something I think in our world as developers we overlook all the time. That is, if someone tries to log into your Facebook account, happened to me the other day, in fact, I've not used Facebook in years, got a notification saying, hey, someone's just logged into your Facebook account from somewhere. You get an email that says, hey, this has happened. But if we're using API keys issued to us by a service, we don't get alerted by these services often that, oh, someone has connected to our API with your API key from an unknown IP address, one that you've not connected to from before. And we're not typically monitoring that sort of behavior. If you go into many of the platforms that you use on a regular basis, they do keep a log of who's authenticating against their API with your credentials. But people aren't necessarily reviewing those often. So consider that as a takeaway. Maybe go home and have a look at some of the access logs for your API keys. So, individuals or systems should be granted only the minimum access necessary to perform their tasks. What we're essentially describing here is the principle of zero trust principle or least trust principle. There's all kinds of different acronyms that this effectively describes, but essentially, we shouldn't be giving people the keys to our kingdom and letting them do everything that they want to do. You wouldn't invite a stranger around to your house, or you wouldn't invite the delivery guy in and say, oh yeah, come in and sit down at my computer and go through my online banking, for example. Yet, essentially, that's what you're doing if you have one password that you use everywhere, or you have one method of authentication, one barrier to access them. So this is a principle that we try and follow, or we should try and follow, as closely as possible in everything we do. That's everything from when we create let's say a SQL connection, a database connection, we make sure that we have a specific, defined purpose for that account that we're creating, for that credential, and make sure it only has access to do the things that we want it to do. So if you're creating a SQL user, it only can write to these certain tables, or it can only read from these certain tables, it can't see anything else. And then you use it for that one specific purpose. People love to reuse credentials and API keys in their applications and say, yeah, we're going to need to integrate with Stripe or SendGrid for some kind of payment or email thing, and we'll just use one API key for the whole application. No, it makes it really difficult to restrict that access down. You end up giving far more permissions than actually you probably think you want to do. So consider that as well. We're going to look a bit at ways you can do this quite nicely in the .NET space, and also with some common providers that people integrate with. Now, I'm not going to tell you to do this, but if you were inclined to go to GitHub, GitHub's got a fantastic, powerful code search feature. It allows you to go on there and you can type basically anything you want and search the world's public open repositories. I'm not suggesting you should do this, but if you were to go there and you were to type something like DB context, which is a common convention used with Entity Framework, you might find some people who accidentally pushed some connection strings, some database connection strings, up to GitHub publicly. Okay, fine. That's not the end of the world, right? Because probably these are all pointing to local environments or something. Well, you'd be surprised. I'm not saying you should do this, but if you were to go there and you were to copy and paste some of them and maybe have a go, you'd be surprised at how many you can actually connect to their database server. Even if they're not a credential that you can connect to, they might give you some insight actually into the person who's published the code and could expose some other vulnerability here. A colleague of mine, a former colleague of mine, posted an open source project on his GitHub account with a local connection string checked in to the repository. Big deal. It had a local host user for the server, local host name for the server, an SA username, but the password was rocket123. Not notable. But if you go to his Instagram, you quickly learn that Rocket is his pet Jack Russell. And suddenly, this exposes quite a lot of insight. This guy is probably using that password in a load of other places. So if you wanted to go and try and find his various accounts, his email address is assigned to his GitHub user. It's public. You can download the GitHub repo, find his email address. You've got a likely password for that person, and you're in, basically. So consider even pushing the most benign secret that you think is not going to let anyone get into anything could actually expose a whole bunch of information. I'm not saying you should do this. Legal disclaimer. Okay, so how are we managing secrets? In .NET has a feature called user secrets that people maybe don't know about. You don't have to be checking those secret values into your source code. Instead, the user secrets allows us to move all of our secrets up a level, effectively, outside of the repository and stored somewhere else on our machine. In .NET, we have... I didn't ask if people are .NET developers, did I? Are people .NET developers? Are people not .NET developers? What are we dealing with? Go? Cool. Anyone else? Cool. Okay, fine. So principles are basically the same. I'm a .NET developer. So in .NET, we have a convention called appsettings.json, which is where you might store your configuration. You could think of this as a .env file or something like that. This gets checked into source control in most cases. And in my case here, I have a SQL database connection string in my application. It's not a real connection string, do not worry. In this case, I've built a .NET application that does something very, very straightforward. All it does is loads in the configuration and prints out some values into the console. So if I run this here, you'll see that it's going to print out my DB context value, just like this. This is reading straight from my appsettings.json file here. But what I can do is, in .NET, I can run .NET user secrets init. And what that should do, it has. Where's it put the file? That's a good question. Okay, it's added a reference here to my to the file, and it should have dropped it somewhere in here, but I can't see it. Excellent. Well, never mind. It's basically created a clone of that appsettings.json file, and in doing so, I can then layer my keys over the top of that, and that's just going to store a file on my local machine that is not then checked into source control. I can safely delete that connection string, and my application will still continue to work. If you're a user of Microsoft's Visual Studio or a JetBrains Rider user, any JetBrains Rider users in? You'll know about it. They've already told you probably. They love telling people about JetBrains Rider. Sorry. But the chances are, in those IDEs, there is a way of managing this through a graphic user interface as well. So you can generally right-click on your project and say, manage my secrets, and it will handle all of that for you as well. In VS Code, there's a plugin that does it, but yeah, there's various different ways of doing this, and it will move your secrets out and up out of the repository. You can effectively think of this as setting local environment variables for your development experience. So of course, we've moved all of our secrets out of the repo now. That's great. What about when we've got other members of our team that want to then get started and up and running with using the application? They're going to need the passwords and the API keys to develop locally too. Well, of course, we share that around on Slack. We don't, but we laugh because probably the chances are sometime in the last year you've shared a password on Slack or Teams or something with someone. And whilst I joke, it's very tempting to say, oh, here's just all of the API keys I needed locally to get up and running and paste that to somebody. And suddenly we've got a complete, uncontrolled exposure of those credentials. If you're cycling things regularly, yes, it mitigates the risk, but it doesn't eliminate it. You can't necessarily control who has access or who eventually gains access to that. If someone's Slack account were to be unauthorized, have unauthorized access to it, someone else could get those credentials. Yeah, it's not a wise thing to do. But what we can do instead is, there's supposed to be another slide in there. We can use a password manager, and that seems slightly insane, but we've been told to use password managers for all of our account passwords. Why aren't we using them for our API keys, credentials, things that need to be set up locally as well? And what people maybe don't realize is a lot of these password manager tools, like 1Password, can store physical files. So I can store that JSON file that are all my user secrets inside the password manager. The benefit of that is the password manager probably has a user per role in your company, so everyone has their own user, which means there's tracked access for who's opened that file and who's actually then gone in and changed or opened or read that file. More so in .NET and other platforms as well, but I'll use .NET as an example. You can actually connect those password managers straight to your application, should you wish. So you can connect 1Password, for example, to .NET, and through a concept called configuration providers, they can effectively provide those values to your application. You can authenticate with your password manager through like an environment variable or through a local key, a local context where that user's logged in, and you don't then need to be passing API keys around either to go and access these secrets. That's kind of cool. So if we look quickly here at my program, I've basically created a custom configuration source here. And what that allows me to do is through, here it is, register my own configuration provider. this could do anything you want. It could talk to your password manager, it could talk to an internal system, an internal database, literally whatever you want. And from there, it returns a list of values. Very, very contrived example, but in my case, my custom configuration provider returns this super secret value, which my program is then going to export here. So when I run this again, my .NET run command should now return to me, there we go, my SQL value, which is coming from the app settings.json file or your local secrets, but then I've also got this other value coming from some other method that I've then provided programmatically to my application. That's pretty powerful. I've got a cool example now of what happens when something goes wrong and you maybe check in a secret that you're not supposed to. So in my case, if we close out all of this, I've got an email service in my application, and that's responsible for talking to the SendGrid API, and through SendGrid, send an email. And SendGrid requires an API key to authenticate, so I'm going to need to have some way of providing that API key to my application. The way I'm going to do that is through this API key field in my app settings.json file, and I've got a GitHub repo here. This is what I'm talking to. It's a private repo, so don't worry, and that's where I'm going to check my API key into. So I've got SendGrid open here. I'm going to click Create, and this pops up a dialog that allows me to choose my API key. So we'll just call it API key. And then it lets me also choose which access I want. I can give it restricted access, billing access. I'm not quite sure what I need it to have access to, so I'm just going to click Create. And it's going to give me a nice API key. We can't show it to you ever again, though, so make sure it's copied. Brilliant. Copy it here, paste it in, and that's all good to go. So now I've done my change. I'm going to go to Git here, and I'm going to just say added send. Don't do it. Added SendGrid API key. Commit it, and push. So if we just check over here in GitHub, we'll see that I've added my SendGrid API key, and you can see that commits there, and that's all good. And then, unfortunately, my senior developers come along and said, what the hell's that? We shouldn't be checking in secrets. And we go, yeah, fine, my bad, really sorry. Let's sort this out. So there's a few things that can happen here. First and foremost, you can just revert the commit in Git, can't you? So down here, we can just say git reset head back one. Actually, no. I want to reverse the commit instead. How do I do a reverse commit in the CLI? I can't remember. Revert, thank you. Is it git commit revert? Git revert. And it head that one. There we go. Cool. So what? Oh, for God's sake. Fine. Let's do that again. Git revert head. Okay. Yep. Cool. So it's reverted it, and that's all good. So I can now do a git push. That's brilliant, because if we go over here and see now, yep, fine. If we go to my app settings file over here,
I think you need to just do head, not head that one.
Thank you.
So now you play head that one.
Yeah.
This is usually how this plays out.
Thank you. You're so right. Okay, let's refresh this and try it again. So I've just pushed that change. Excellent, cool. The API key's gone, hasn't it? Fantastic, it's no longer there. So crisis averted, no. You're wrong. It's still there, because I can go to the history, and I can look in the history, and I can still go back to that commit, where I can see my API key that was added. So, that's really not ideal, right? So instead, to fix this, we actually have to go and rewrite the Git history and remove this from the history. And that way, of course, it won't be there. So if we go back to the repo and say git revert, no, git reset. I'm going to do a hard reset, head back. I guess it's 2 commits now. 1, 2, 3. And I've done that the wrong way around as well. Excellent. So what this is going to do is effectively reset my is going to reset my repo to a point in time before I added that commit. And what I then need to do, because I've effectively rewritten history here, is push my changes, but I have to force push, which is a destructive action in Git. And doing so actually yeah, rewrites the history. It means anyone else that's cloned this repo down is going to have to reclone their repo as well, because they have now a different history to what I've pushed to the remote. But if we do that, that's all great and good, because we go over here and we refresh, and we look at the history now, and ta-da, it's gone, right? Wrong again. It's still there. It's still there in the background. Look, if I refresh this, the commit's actually still there. So if I have the commit hash from some previous time when this repo was available, I can go back and still see that key. It's always going to be there. GitHub does come along and periodically goes and cleans up these orphaned commits, but you don't know when that's going to happen. There's also so many other risks with this. If someone has cloned this repo or forked it, perhaps in that time, well, yeah, they can still have it. It's still out there on the internet. There are tools out there that do GitHub repo mirroring for some strange reason. I'm not quite sure why. But there's websites out there where you can go and you can see GitHub repo histories for repos that are no longer public. That API key is now always out there. So how can we avoid this in future? Now, I'm going to show you something else that's quite handy that GitHub has. And I'm just going to go back and recommit that change. And let's just push that up one more time. Added SendGrid API. Cool. And push. So going back here, we'll see I've now added the SendGrid API key in again. That's wicked. But the even cooler thing is GitHub can actually help you realize when your API keys have accidentally been leaked. Let's click Done. So I have this SendGrid API key that's been created, and you can look in the SendGrid UI here, and you can see that it exists. If I was to do an action that maybe inadvertently exposed this key, such as making my Git repo public, GitHub is going to do some magic under the hood and actually notify me or notify SendGrid of that change. So let's go and make the repo public. Why not? Change the visibility, make it public. Yes, all the disclaimers. Oh, I've got to put a password in now. Great. Is it going to make me two-factor auth? Ooh, probably should have. Anyway, doesn't matter. I've now got a public repo. If you were to go to that URL, github.com, Callum Whyte, all your secrets, you can get my SendGrid API key. Except you can't, because in the background, SendGrid has revoked the API key. There we go. It's gone. How's this working? What magic is this? Well, GitHub has a fantastic scheme called the GitHub Advanced Security Program, and they've got some partners involved in that too. And through that, they have, I think, about 1,600 different partners they've integrated with, where the partner tells them, these are the patterns that our API keys follow. And when GitHub sees something that looks vaguely like one of those patterns, they will then call SendGrid, in this case, and say, hey, SendGrid, this API key was just exposed on GitHub. And then it's completely up to SendGrid to decide what they do. In this case, SendGrid immediately revokes the key, sends me an email to tell me what's happened, and no harm done, in theory. Like, the second that that's happened, it's immediately revoked. You can say the same thing for Stripe, you can say the same thing for PayPal, and I'll be honest, it's saved my butt on a number of occasions just by inadvertently doing this. So GitHub is great. It doesn't need to even be the latest commit in the repo. It will scan every commit at the point you make your repo public. So incredibly powerful. If you're not in the GitHub world and you're using something like Azure DevOps, good news for you. There's also Azure DevOps Advanced Security, but it's an enterprise feature. So yeah, GitHub's a great way to do this. You could, of course, also build your own sort of scanning tool that looks for other secrets that you don't want to be leaking, and do things that way as well. But yes, don't trust Git. Git's a fantastic tool, but as soon as something's written there, it's effectively written there in perpetuity publicly. And I think the better thing to do, rather than trying to clean that up, is just mitigate damage by closing off keys and restricting their access, etc. Okay, there's some other ways of storing keys that don't involve checking files into source control. One of those is a secret management tool like Azure KeyVault. Of course, this exists in basically every cloud. We've got, I think it's AWS Secret Manager. There's a Google. Anyone using GCP? No, one guy. Cool. You're keeping them alive. Oh, I'm so sorry. So sorry. Someone got a Google partnership and's got a load of credits to spend. Yeah. Yeah, okay, so yeah, Azure KeyVault is the Azure flavor of this tool, but essentially the idea is it's a centralized store for managing your secrets with a lot of granular control, and it integrates seamlessly with your application as well. So in the case of a .NET application where we've got our different sections that are available in our app settings JSON file, you can essentially override these directly by creating a key that follows a certain pattern. So in my case, it's section, and then the key that you want to override. And then at runtime, you can tell your application to read keys also from Azure KeyVault. And in doing so, you can avoid checking anything in at all. In my application that I've got over here, I've got that little example, and I have wired up Azure KeyVault to also run in this too. So if we just go back to the very basic demo I had, which is just reading the files out of the app settings.json file. Let's just clear out all of that. If I do .NET run is, what is that doing? Does it think it's .NET 7? Why? Maybe it's .NET 7. Oh, it's .NET 7. I think I reverted the wrong thing. Live demos, right? Let's try that again. Yeah, no? Yeah, maybe. Cool, okay, ignore the warnings. What it's done here at the bottom is, just like it was supposed to, it's output the relevant keys that I was expecting. Now with a single line of code here, this line here, builder, add Azure KeyVault, you add a NuGet package, you give it your KeyVault endpoint, which is also wrong now, that's fun, and you pass it in some credentials, which is this default Azure credential. And in doing so, that can now connect straight to my KeyVault instance that I've gone and created in Azure. Again, ignore the warnings. But it says at the bottom, I don't know if you can see, hello from Azure KeyVault. And so that's a key that I've provided directly in my KeyVault in Azure. Let's go have a look at what that looks like. So here I've got my a resource group that I've created called All Your Secrets. And inside it, I've provisioned 4 resources. We're going to talk about all of these individually, but it's an app service, a server effectively, and a KeyVault for now. When you jump into a KeyVault, KeyVault lets you manage all kinds of things, from keys to secrets to certificates and more. The secrets feature is what we're looking at today. And in this case, I've created a key called super secret, which is exactly what my application is expecting. So at the point my application runs, it calls that Azure KeyVault endpoint, and it retrieves the keys that I've requested it to do. If it doesn't exist in the local configuration, it will try the other sources, including the KeyVault source. So in my case, my super secret key here. When you create a new key, you're allowed to say, you give it a name, that's the name of your key. If you're targeting a different section, you use the dashes, of course. You give it your secret value, you can give it a comment, and you can set activation and expiration dates of these. So if you only need to give an application a key for a certain period of time, perhaps for a deployment or for a certain process, you can set and manage this directly in here. You can even turn keys on and off. I'm able to do this because I'm privileged and able to control this Azure KeyVault, but not everyone can. I can give people read access to this KeyVault or even to individual keys, which makes this super powerful. So I can now grant that least trust policy and start applying, this system or this server should only be able to access this one key, for example. It makes it very easy to revoke keys when something goes wrong. And like I say, this applies to certificates and all kinds of other things as well. So if you're using certificates in Azure, KeyVault is actually a fantastic way of managing that across your entire fleet of servers, PaaS platforms, etc. How have I connected to that then? Because I'm not using an API key. Like, there's surely some magical way that I've authenticated. Well, yes, there is. In this GitHub code space that I'm in, I've actually authenticated with my Microsoft account against the Azure CLI. So when this boots up, it's not using any credentials other than the credentials that I have authorized my machine to use. If you're using Visual Studio, or maybe it doesn't work in Rider, but if you're using it does, cool. You can, if you're logged in with your Microsoft account or an account that you're able to use to authenticate against this, it will use that principle that you've already got authenticated locally to authenticate. It's the same thing I was saying about a password manager a minute ago. You're probably already authenticated with the password manager or authenticated on your internal network. So let's use that rather than using the API keys that people throw around in configuration. The other benefit here is we can actually start exposing this to different parts of our infrastructure. So there is a feature called Azure Managed Identities. Now, what this lets us do is tell one part of our infrastructure, you've got permission to talk to this other part of our infrastructure without any API keys. Azure, internally behind the scenes, is doing all kinds of authentication there anyway between services, and this essentially lets you configure and control it. Azure Managed Identities, or User Managed Identities in this case, lets us say, for our, let's say our app service, you should be able to talk to the KeyVault, and only you should be able to read from that KeyVault. We'll assign you the relevant role to say you can read from KeyVault. So you can do it through the Azure CLI, of course. You can go AZ web app and assign an identity, and then also assign a role. In our case, a KeyVault secret user. That role lets our application read from KeyVault, but not do anything else, not write to it, not literally nothing else. Whilst, yeah, you can expose other things, but again, following that least trust principle, we want it to be the minimum access possible. You can, of course, also do this directly through the UI. So what I've done here is I've created this all your secrets identity, just to show you what's possible. And in here, it's currently connected to nothing. It has no roles. It can't do anything, really, with my resources. But if we go to KeyVault, I can now start to assign access. You go to the access control plane, and from here, you can add a new role assignment. From within there, you get this whole host of massive amounts of roles, but as we said, you can be an administrator, you can be like a reader, or you can manage these things too. The descriptions tell you exactly what these roles can do, and in our case, we want to give the minimum amount of control possible to our user, so we'll just go with the user. This allows the API to be used to read secrets out of KeyVault and basically do nothing else. So we'll click Next. And then here you can choose who we're granting this access to. This could be an internal user in your organization based off of Entra ID. I refuse to call it. It's Active Directory. Let's not call it Entra ID. Or you can assign that to a group, a team. Perhaps you've got a development team that needs access to these keys. That's all good. Or you can do it to a managed identity. And that managed identity can then be used to control which parts of your infrastructure can see and talk to the other parts of your infrastructure. Let's select that today and click Get Members. And from there, I can select the managed identity that I've already created, and I'm going to give it permission to talk to this resource. Review, assign, bingo, done. It was that quick. Of course, we now need to tell our app service, hey, you should be using this managed identity to go and talk to other services. And to do that, you can assign that through the UI as well. So you go to your resource, and in this case, down to Settings and Identity. And at this point, you can go to your user-assigned identities, add a user-managed identity, choose the one that we just created, hit Add, and that's done. So it really wasn't that hard. Probably about the same amount of effort as it takes to go and provision an API key for something and check it into source control, push it up, and do a deployment maybe. This is all just managed directly within the portal or through the Azure CLI if you wish. So really powerful, really intuitive and easy to set up. And now I've got my two resources able to talk to each other, or in fact one able to read from the other, and it can only do what we've told it to do, nothing else. Okay. Let's quickly talk about some of the other things that maybe we've overlooked here. We've talked a lot about secret management, but there's some very common attack vectors that hackers are trying to exploit nowadays. These are the three most common ways people are exploiting applications. Permissions is the obvious one, and we've spoken about that a lot. Following least trust principles means you reduce a lot of that risk. You don't inadvertently expose access to something. We're talking at the most basic level, IP restriction on access, or even better, restricting access down to far more granular level. Account takeover, similar to permissions, is another very common attack vector, unfortunately. I've seen someone managed to steal google.com a few years ago. Did anyone see that? And through that, they obtained access to somebody's Gmail account that had access to a Google admin portal that then gave them access to something and something and something, and they actually stole google.com for a whole 30 minutes. Nothing really happened. And the final one is supply chain attacks, which is a way of someone injecting something into a dependency that you supposedly trust, and then bringing that, injecting code that is doing something malicious. These are two common ones, and I'm being unfair on mock here, to be fair. But UAparser.js is a Node.js library that's downloaded about 10 million times a day, and the author's GitHub account got hacked. And someone leaked a bunch of malicious code, and of course people blindly trust and just install that version. Similarly, mock, the author decided he was going to put some code in there that every time you ran a build in Visual Studio or .NET, it would scan your local Git folder and get hashes of all of the email addresses for everyone that had committed anything to your repository, send them to a server, and check if you were sponsoring that author on GitHub, which I understand the intention, but the execution's poor. Your organization would lose their minds if they thought someone had code that was scanning for email addresses on every developer's machine, right? Probably. What I'm saying here is you've really got to trust, you've really got to look at the dependencies you're taking and analyze exactly what they're doing, analyze the risks, and then pin to a specific version. Very common in the JS world to have floating versions on things. Don't do that. Pin to specific versions that you trust, make sure you trust them, make sure you vetted them, validated them, etc. So, as a very quick summary, this is what our production infrastructure might typically look like. We've got a bunch of resource groups. We've got a KeyVault inside there for different environments. Typically, we will have different versions of different keys for different environments, and so we can then manually control the access that those different keys have to say, okay, the development environment, it's fine for people to access those keys from their local machines, just with their Microsoft Entra ID or user. Or for the production environment, actually we're going to use managed identities, and only the production resources can talk to each other, nothing else can. This is all great, but still it's possible that a leak could happen. You could accidentally leak some credentials through Git, etc., like we've seen. So this is actually the way that we track it, and it's super old school, but we've got solutions with thousands, and I mean thousands of secrets and keys in them. And we have created a Google Sheet that tracks every single key we have issued. And I'm not saying the physical key, but we give it a name. And so that name is then used for its specific purpose in a specific place in our application. Again, least trust principle. We will configure that key to only have access to do the things that it needs to do for that specific purpose. And then we pop them in the sheet. We say when were they created or when were they last cycled. And then we also say the area of our application that this actually affects. So that if we have to revoke a key, it's not a key that's used in 10 million places across our code base, and we've now got to go and change the entirety of our infrastructure. Instead, it's one service that is affected, or it's one aspect of our system. So in this example, which is obviously not a real example, we've got the vendor column, which has Stripe and SendGrid reCAPTCHA and Google Maps inside it. We're using Stripe for taking payments through our checkout. So we've then got the domain of our business that it applies to. So store, checkout being the purpose, and then an environment here. So we're naming our keys, giving them a kind of alias, and naming them this way. When I set up my SendGrid API key earlier and I just wrote API key, that's where you put a meaningful name against them, and then you can track and you know exactly which key's been affected and needs to be revoked, and then the implications that it has, because we're specifying the area of our application that it affects. If you can twin this with some kind of architecture diagram, I don't think people are doing this very often. They're not mapping out how all the different parts of their infrastructure talk to each other, and which APIs and the keys, or the names of the keys, are used. So I advocate for a process like this. When you've got thousands of secrets, it really makes a big difference. As my final slide, so a summary of some ways you can limit attack vectors. Permissions on API keys. Let's stop issuing broad general API keys. If we can follow these least or zero trust principles, it massively, massively limits that attack vector. If you have designated keys for designated purposes, it makes fixing things when something goes wrong later way easier. And finally, I would say we should be thinking about our configuration as part of our infrastructure. Someone needs some oversight on this. Developers are great and they can spin up these services and connect this and that. Someone needs to think and plan this through and talk about the risks. I know that sounds really boring. As developers, we just want to get on and build stuff, but someone has to be in charge of this. Think about life beyond keys, other ways of authenticating through managed identities, through KeyVault, or through even using your Entra ID auth. And with that, that's me. Thank you so much. I'll be around all day on socials here. Hope you enjoy the event.